Hey guys, welcome to the week 4 workshop. My name is TG Sido and today we're going to focus on loops. So let's get started. You'll see a link in the description for this notebook. Go ahead and click on that so we can get right into it. And be sure to try all these exercises out before you actually see the solution. The solution will also be linked in the description. Alright, so let's get right into it, guys. Awesome. So for task 1, use a for loop to print out all the numbers from 0 to 5 inclusive. And we see the target output 0, 1, 2, 3, 4, 5. Gotcha. So from this past week, we learned that range of n, when n is a positive integer, can actually help you get the numbers from 0 to n minus 1, right? 0, 1, 2, all the way up to n minus 1. So we can actually use that here. So we know that we want to get 0 to 5. So let's actually use range of 6. And then we'll use print I to actually print out each of the numbers in that sequence. So we'll say for I in range. Gotcha. And then we'll print out I over here. Awesome. So we print it out and we get the output just as we expected. And now for task 2. So use a while loop to print out all the numbers from 0 to 3 inclusive. Hint, use a condition to ensure that you stay in the valid range of numbers, 0 to 3 inclusive. Okay, so we see the target output 0, 1, 2, 3. Go ahead and try this first on your own and then come right back. So let's check this out. What we can do over here is we need to use while to start this out. And now we need our condition. We know that all the numbers actually need to stay in this range 0 to 3. So let's use something like this. Num less than 4. Okay? And then we also want to start off our num. So we can say num is equal to 0. And then we'll go over here, put that colon. We'll actually print out the number. And then we'll increment it. And so we'll think about this, right? So basically we start off with a number, we check the condition. Is it less than 4? If so, we can actually print out that number and then increment it. But eventually, say when this number does become 3, right? We'll print out 3 and then we'll increment, will become 4, and then we need to check the condition again, right? 4 is not less than 4, it's equal to 4, so it'll jump out. And that'll ensure that it doesn't actually print out 4 or any number beyond that. So let's actually go ahead and run this. So just as we expect, we see the 0, 1, 2, and 3. We're all good. Okay, and now for task 3. So use a for loop to print out the following sequence of numbers. 50, 30, 10, negative 10. Okay? And so the hint over here is consider using range, k, and in step, right? We need to specify 3 numbers over here. And remember that if step is greater than 0, then all numbers in the sequence must be less than n. And if step is less than 0, then all numbers in the sequence must be greater than n. Okay, so what do we notice here first and foremost? So what is our step, right? We see 50, 30, 10. Okay, so we're going down in a step of 20. So we know that our step needs to be negative 20. Gotcha. Okay, and where do we start off? 50. All right, so k is going to be 50. And what about our n? What does our n actually have to be? So if we're going all the way down, what do we know about that? We said our step is going to be less than 0, so we need to go all the way down here, right? And all numbers in the sequence must be greater than n. Okay, so if we have all of these numbers are in our sequence and these need to be greater than n, what is a potential number that we can select for n? There's actually going to be more than one. I'm going to select one of them here, but let me know in the comments the other possible n's that you can actually use. So over here, I'm actually going to use negative 11, right? So all of these numbers here are going to be greater than negative 11, but I'll use negative 11 for my n. So let's go ahead and write this out right now. So for I in range, and we said what's our k? That's going to be 50, right? What's our n? We decided to choose negative 11. And we know our step, we're going down in steps of 20, so that needs to be negative 20. Awesome. Let's go ahead and print out I. So let's go ahead and run this. Okay, and so just as we expected, we have 50, 30, 10, negative 10. Okay, and now for task 4. So take in user input for an integer n, use a for loop to add all the numbers from 0 to n inclusive, print out the sum, and hints, use the sum variable, and also what does range of x produce. So think about that. We said before for any positive integer n, range of n gives you 0 all the way to n minus 1. And so think about that in this particular context. If we want to get all the numbers from 0 to n inclusive, right? We do want the n in this case. And then here's the target output. Enter a positive integer n. So this is the part where we actually ask for the user input. They type in their number. And then finally, we'll print out the sum of all the numbers. We put in whatever that n is. And then finally, that sum that was calculated. Okay. And so we need to use a for loop. They said use a sum variable. And also we can, they also said range would be a good hint. So thinking about this, right? We know that we want all the numbers from 0 to n inclusive. We do want n. So let's actually say range of n plus 1. So we can actually include that n this time. And then also we need to use that sum variable. Let's actually add to the sum variable as we see the numbers. So first and foremost, we can say sum is equal to 0. And now we actually need to get the user input. We've used input in the past. And so we'll say n is equal to input. And we can say enter a positive integer n. And I'm following the message that we see in the target output. Okay. And then what do we know about input? It actually gives you a string back. And we actually want the numerical integer form. So let's actually wrap this with an int. Okay. So now we used our built-in over here. And now that we have our n and we have our sum variable, let's actually go to our for loop. So we can say for I in range n plus 1. Why am I using n plus 1? Didn't we just say n, right? We actually want to include n in this particular case. And so any number we specify, we go up to that number minus 1. So since we've specified n plus 1, we will actually get n, and we do want n. Okay, so now we can say sum plus equal I. Gotcha. So now we're adding to the sum variable. At every iteration, we're building up that sum, adding up all the numbers from 0 to n inclusive. And finally, once we have that sum built up, outside of the loop, sum should have its correct value. Now we can print out the final message. So let's say print sum of all numbers from 0, right? And this isn't just coming from my brain. It's coming from right here, guys, so you guys can follow that too. 2, right? And now we can say comma. And let's actually say what our n is. And then we can use something else. Another string is. And then finally, we can actually put our sum. So now that we have this, let's run it and let's test it. Let's try 3. Cool. So we got what we expected. Additionally, let's try it another time for 2. Okay, and so we got, right, 3 just as expected, 0 plus 1 plus 2, that gives us 3, so we're all good there. Alrighty guys, let's move on to the next one. And now for task 5. So, use a for loop to iterate over all the numbers from 0 to 5 inclusive, print out the sum of the even numbers, and the sum of the odd numbers, okay? So we have our even numbers over here and our odd numbers. And hint, use the two sum variables, or use two sum variables and the mod operator to actually help you solve this problem. Okay, so looking at this, we see the mod operator being used. What do we notice about the even numbers? 0, 2, 4, right? With respect to mod 2. What do we notice? Is there a little pattern that we see between the odd and the even numbers and the actual result that comes out of mod with 2? Hopefully you guys see it. Let me know in the comments if you see it right now. Let's actually get started and actually build this thing out. So they said use a for loop to iterate over all the numbers from 0 to 5 inclusive. Let me go ahead and do that over here. For I in range 6, right? Why am I using 6? Because I do want to include 5. And they also said that I should use two sum variables. So let me go down here. Let me use an even sum. And I'll set that to be equal to 0. And also let me get an odd sum too. So now that I have that, I want to actually go in here and basically check. If the number I'm actually hitting in the sequence is odd, let me add that to the odd sum. If it's even, add it to the even sum, okay? And so how do I check if it's actually even or odd? Basically using this in this pattern that we just noticed, let's actually do it. So if I mod 2 is equal to 0. That basically means that it's even, and I'm using this little comment just to show that over here. And else, I know that it is odd. So for the even part, I know that I is even if I get here. So let me actually add it to my even sum. Okay. And now down here, let me add in the else, I know that I'm odd, so I can actually add I to my odd sum. Alrighty. Okay, so now that I have this, I will have gone through all the numbers once this loop finishes, and I would have created and populated even sum and odd sum so they have the right sums. And now I can actually print out the final target output. So let me go ahead and print this out. So I'll say even sum, right? Just following the way that they did it here. And so let me say even sum. And now over here, I want to get odd sum. Gotcha. Okay. So now that I have this, I think I'm all good to go. Let me actually run it. And so we get our even sum 6, odd sum 9, just as expected. And you can actually confirm that over here, right? So what's the sum of our even numbers? That's 6. And then over here for our odd numbers, we have 1 plus 3, that's 4, plus 5, that's 9. So just as we expected for our odd numbers. Alrighty guys, good to go. And now for task 6, collapse conjecture. Definitely look this up on Wikipedia, super, super cool. Alright, so basically it says starting off with any positive integer, we can reach 1 with the following procedure. Have that positive integer n. If n is even, let's actually divide it by 2, update it. If n is odd, then let's actually multiply n by 3 and then add 1, update it again, and basically repeat this process until n is actually equal to 1. So keep this in mind. This is actually going to inform some of the code that we write. Okay, so this is the target output. First and foremost, we want to get the user input to actually determine n. In this case, the user typed in 5, and then we see these statements out here. So they typed in 5. 5 is an odd number, so let's multiply by 3 and add 1, and so we get 16. Now n is 16. Now over here, 16 is an even number, so let's divide it by 2. We get 8, and so on and so forth until we actually get to 1. Remember, 1 is a stopping condition, and then we actually want to print out the number of steps it took to get to 1. So with all this in mind, let's get to the code. Please, please, please try this on your own first, and then come and watch this. All right, so we need to actually get this user input n. So we'll say n is equal to input, and we'll say enter a positive integer n. Gotcha. And so now that we have this, remember input always gives you back a string, and we do want the numerical integer format. So let's actually wrap this with an int. Cool. And we do want to track the number of steps. So let's actually use a variable for that. We'll call that num steps is equal to 0, and we'll update that as we get to each step. So now for this, where does this come from? As we know, we're actually breaking down n so we can bring it all the way to 1. And so we will actually need a loop. And our stopping condition basically is once it gets to 1, right? So let's actually write it in this way. So while n is not equal to 1, basically saying that we want to continue this process of breaking n down while n is not 1. So inside here, right, we have to deal with n depending on its parity. So if n is even, do this. If n is odd, do this. So we'll say if n mod 2 is equal to 0, what does that mean again? That means that n is even. And else, we know that n must be odd. So in this particular case, what do we need to do? We need to print out a little message when it's an even number, and then actually update that to be half of what it was before. So we'll say print n, and we'll say is an even number. So let's, and so we want to escape this apostrophe. Let's divide by 2. And now over here, we want to say n, integer division 2. And so we've printed this out, but we actually haven't updated n. So let's update n right now. So we'll say n is equal to n divided by 2. And so now we've updated n. Now let's actually handle the odd case, right? Where we actually have to multiply by 3 and add 1. So we can reuse a lot of this, just change a couple of parts. Okay, so it's an odd number. And now instead of divide by 2, let's actually multiply by 3 and add 1, right? Is this good? We're just kind of following this. Looks good to me. Okay, and so now instead of divide by 2, let's do 3 times n plus 1. And so we've printed this out, but we actually haven't updated n yet. So let's make sure to update n. Awesome. Okay. And so now that we have that, right, in either case, we actually took a step to break n down further. So let's make sure that we actually update num steps. So we'll say plus equal 1. And now after this is actually sufficient because it's actually updating n at each iteration. And basically we're tracking the number of steps. So finally, when we get outside of the loop, we know we're done. We know we're solid. So we can actually print out this final message. So we'll say print all done in, right? And now let's actually put num steps. Ooh, sorry about that. Num steps. And now we can actually put over here steps. So now that we have that, we should be good to go. Let's run it. Let's try 5. Gotcha, right? So we go 5, it's an odd number. Multiply by 3 and add 1, we get 16. Then 16 to 8, 8 to 4, 4 to 2, 2 to 1. We're all good. And let's actually try for another number. Let's try something like 17. Whoa. Okay, that was a lot of steps. Cool. But we're all done with this one. Definitely try this out. I think this is one of the coolest problems.